everyone, welcome back. We are picking up right where we left off in the last video, where we had just created a scene in ThreeJs and a bunch of spheres to sit in that scene. What we're going to add today is a bit of animation. We're going to make it so that these balls, just reload it, will gently push each other away so that they all have a little bit of space between them. Kind of like that. Let's change the camera angle so you can see that a little bit more clearly. Now from up above, they just kind of space each other out. Cool. So let's fire up our live server. Good. And here is where the code was when we left it. Okay? To add the animation I mentioned, we're going to go into this getBall method and add a couple of things. We're going to add some more properties like velocity, and we're going to add a method to update each ball. And then we're going to go through all of the balls, all 20 of them in this case, or 30. Let's go. First thing we'll do is update the getBall method. I'm now, instead of simply returning that mesh, which I call ball, we're going to return a JavaScript object that contains a mesh property referring to that mesh that we created. Okay, and this will break because now we need to add that mesh to the screen, to the scene rather. Next thing I want to add is an update method that will get called in our animate method. Okay, and right now it does nothing. Actually, no, it does something. Let's say it takes our mesh, rotation, plus equals some value, rot. Oh, let's give it, rot. Let's give it rotation x. This is just a temporary variable called rot, and we'll give it a value of between 0.1 and or 0.2 and a negative 0. Now I've saved it. Nothing changes because we haven't added the part where we tell each ball to update. And to do that, we'll say balls.forEach ball b.update. Okay. And now that's going to fail. In fact, there's an error now too. I think that is the hotkey. I just didn't have the constant there. So balls is not defined. Whoops. Const balls equals. Now balls is defined, but they're not animating, and that's because we didn't add each one of these balls to that ball array. Balls.push ball. Great. Now each one of them is randomly rotating. And that's kind of cool, isn't it? That's not what we were looking for. Let's comment that out. But that's just to show you that now with each frame, each time this animate method is called, we're calling this update method. A little bit of housekeeping before we go on. I wanted to create a couple of variables. Let x equal this value. Okay, and let z equal this value. This is now z. Okay, I'll leave the rotation as it is for now. And we're going to add this velocity property. The velocity is something we'll add to a mesh's position with each frame. Okay, just to get us started, I'll just grab this random float spread method. The number you pass in here tells ThreeJS the range in which you want random numbers. So 10 means you want random numbers between -10 and 10. Right? So let's say I want a velocity between -1 and 1. Okay? And in here, I want to update that. Let's say x plus equals velocity dot x, and z plus equals velocity dot z. Okay, I saved it. Nothing's happening. It's because we need to add these lines in our update method. So now all the balls shoot off in different directions. Okay. And they keep shooting off forever. I'd kind of like a way to stop them from shooting off, like to pause the motion. To do that, I need to add some functionality in here to tell this to pause. For example, I need to say, if we're paused, or let's say if we're not paused, if pause is equal to false, then do this update. Otherwise, don't do it. So right now, pause is not defined. Let's just define it. Let pause equal false. Great. And if I set that to true, now nothing changes because we're paused. I want to add some functionality now. I want the code to listen for key presses. To do that, we'll say window.add event listener key down, and we'll give it a method to run every time the key is pressed. Key down, and oh wait, handle. Let's do handle. Handle key down. Okay. Handle key down. It takes an event. And yeah, let's just console.log that event. Let's pull out the console. That's the right one. So there's some keyboard events there. Every time I have the browser in focus and I type a key, I'm going to get this keyboard event. I want the escape key. I'm going to use that as the key to toggle paused and unpaused. So I can see inside this keyboard event, you guys all see that? It has a bunch of properties, most of which I don't care about. I just want this key property, and its value is escape. So inside of this key handle key down method, I'm going to say const key equals event. And what I'm doing is using JavaScript destructuring to take that event object, just pull out the property I want so that I can use it. Const escape equals escape. That's the string I'm looking for. I'm just assigning it to a variable because I like the way it looks in the code. And if the key is equal to escape, then paused variable is equal to not paused variable. This line just toggles the value. If the value starts out as true, you hit the escape key, this is run, and the value will be false. If it's false, then it will be true. It just toggles it. So let's see how that looks. I'm in the browser, I hit escape again, escape. Works exactly as I hoped. Yay! I want to change the way the balls are moving now, so that, first of all, before I change the way the balls are moving, let's change the position of the camera so we have more of like a overhead view, like kind of like that. And if I unpause, they just fly off the screen. Okay. I want to change the way these balls are moving. Right now they're just moving in a random direction. Kind of like that, which is kind of cool. Just changing this back to false so it'll animate by default, and I can pause it if I want. But I want them to all to respond to one another, kind of like the way I showed at the beginning of the video. So to do that, I have to do a bit of calculation. I need to compare each ball to another ball, well, one at a time, and see are they overlapping, and if they are overlapping, how exactly, like what's the orientation of the overlap, calculate the direction to travel against that overlap, and then move them in that direction. That was a lot of words. I'm going to pull up my code on GitHub, which is here in github.com/BobbyRowe, and this is the getting started with ThreeJs. And I have the branch completed part 2, and there's all the code for completed part 2. Here's the part we're gonna add now. I've already got the velocity plugged in. What I want to do now is to calculate the direction of the overlap, and the overlap, I should say. So const direction is equal to new 3, and we'll give that just we'll zero it out. And now, the one thing I forgot to add is damping. Let's define a damping factor. I'll call them damping mults. So const damping mult is equal to 0.98. Here's how we use that. Velocity.x times equals damping mult. And same with z. So this is acting like friction. Check it out. The balls move for a while, and then they slowly stop. If I were to increase the value, so they stop a lot faster that way. And if I reduce it, they slow down, but really gradually. I think 0.98 is a kind of sweet spot for us right now. Okay. Now that direction, that actually needs to not be here, in here. Because I'm going to loop over all the balls in the scene. By the way, this is immediately going to break it, because I haven't defined all balls. I want to pass all balls into that update function here in the animate method. That balls array we created earlier, let me just drop this down to 20 just for fun of it. So now I have access to every ball, and I'm going to loop over them. And for each ball, I'm going to calculate this distance. I'm going to take the first ball, start with this one. Actually, it's not the ball, it's the 3D object that ball has, the mesh. And it's also not the mesh, it's the position property of the mesh. Okay? I'm going to say the distance to the my mesh. This update function is being called on each ball, and each ball will look at all other balls. It's not actually very optimized right now. This code is not optimized. Just a quick note. But it's going to do the trick for our small number of balls. It's going to look for each ball. It's going to look at all the other balls and say, "Are you overlapping with me?" And that's what this calculates. If distance is less than radius times 2. Radius, we haven't defined that. Well, let's define radius. Up here above the geometry, const radius equals, how about 1.3? When you define a new sphere geometry like I did here, it defaults to 1. So now I'm just passing in a value here that's slightly larger. I don't know why it stopped working. Let's have a look. Because distance 2 is not defined. Why? Distance 2. this guy here. Distance. Oh, my bad. Great. It's working again, although it's not calculating the distance yet. We've just figured out whether or not we're overlapping. Now let's compute the direction in which we need to move. We'll do that using this sub vectors. I'm not exactly sure what that means. Subtracting vectors, maybe? Mesh dot position. And then the mesh dot position. Okay, and we're going to normalize that value. And multiply scale. A scalar is a value that has a single value, as opposed to a vector. A vector is 3 values, is 1. And let's just make this value 0.1 for now. It's just a nice small value. Actually, I'll set it to 1. Great. Now we know the direction, but we're still not using that. Let's use it here by saying for each ball, its velocity plus equals direction dot x. And do the same thing for z. Oops, forgot to add that property. So this is going to cause an error. Here's why. We didn't expose the velocity property of each of these balls. Right now, each ball has an update method and it has a mesh property, but it doesn't have velocity, which we've already defined. Whoops. We just hadn't exposed it. It's defined here, and now I'm exposing it here. Wow! So they really exploded. If I zoom out, if I zoom the camera out from the get-go, you can see them explode a little more. Let's go to 52. And I think that's an indication that this value here, this multiply scalar, is way too high. Let's drop that down by a factor of 10. Still too high. Another factor of 10. Oh, now we're getting close. So how about one more factor of 10? See how they push each other apart? Oh, I love that. Let's make this explicit so that the next time we come to visit this code, we'll know it'll be easier to read. Strength equals boom. There you go. And we shrink the size of the balls. Let's make them tiny balls. Still works. Let's make them regular size balls. And that's it. Thanks for watching my video. I hope you enjoyed this. I did. And tune in for more fun stuff coming soon. Bye.